Okay. Or speed is equal to speed v is equal to s by t. Everybody knows that. This the speed v is equal to s by t. Therefore t is equal to what? T is equal to s by v. That will be wrote here, right? Okay. So this is the total time also calculated. Then average speed is equal. Therefore, average speed is equal to total distance, that is equal to s1 plus s2 plus s3 plus etc etc etc, the whole divided by s1 by v1 plus s2 by v2 plus s3 by v3 plus etc etc etc. So in this way we can calculate the average speed of the body also, right? Suppose if the body is traveling its journey with the velocity v1 4 times t1, and with the speed, sorry, with the speed only, not velocity, with the speed v1 4 times t1 and v2, v2 4 times t2 and v3 4 times t3, then average speed is given by, that is a different thing. The body is moving in a certain time interval t1 with the speed v1. Other interval t2, the body is moving, the speed is equal to v2. Another time, interval t3, the body is traveling with the speed is equal to v3. Then also average speed can be calculated. In that case, what is called velocity and time is involved. In that case, average speed is equal, sorry, speed and time. Average speed is equal to distance traveled in the first duration t1 interval, that is equal to v1 t1, v1 t1 plus v2 t2 plus v3 t3 plus etc etc, the whole divided by t1 plus t2 plus t3 plus etc etc, it goes like this. So this way also we can calculate average speed. So when is average speed to be calculated? When the body is moving with the variable speed, average velocity, average speed, and what do you call instantaneous speed has to be calculated. Instantaneous speed is given by simply v is equal to ds by dt. Average speed we have already said how it is to be calculated, right? In terms of velocity and also in terms of time. Next we are coming to is another definition. All this definition already you have studied in lower classes, but for the continuity of our syllabus, I am mentioning every point, so you will be able to do things. But one thing I tell you is that this mathematical lessons I have taught in the previous classes, you will go through every time, and will keep the mathematical formula that we have to apply in physics, right? Don't do any pure mathematical questions in those topics that we don't need actually. But in vector lesson, you have to, in vector lesson, we have to calculate. So we have to do some questions also, but not in what is called other part, just like binomial theorem, just like calculus, just like integration, differentiation, etc. Don't do any pure mathematical questions. But vector lesson, you have to do numerical problems as many as possible. Next is velocity. It is also, velocity is also physical quantity. It is defined as the rate of change of displacement. So what is the speed? That is time rate of change of distance traveled. This is time rate of change of distance displacement of a body is called velocity, right? Velocity. Next is what do you call velocity? The time rate of change of displacement of a body is called velocity. Velocity is a vector quantity. Therefore, velocity is given by same v only small v. Velocity v is equal to vectors divided by t. Okay. It is a vector quantity, and so it can be, velocity can be either zero, that can be negative, that can be positive, etc., etc. But speed cannot be negative. Speed is always positive, right? Okay. Speed is always positive. Speed cannot be negative. But velocity of a body can be positive, that can be negative, and also that can be zero, right? If the a final position and initial position of the body is same, then displacement is equal to 0. Displacement divided by time taken is equal to 0. Then that condition we can say velocity is a null vector. Velocity can be 0. If the body is moving in the that means in the negative x-axis direction or negative y-axis direction, the velocity can be negative. That can be positive if it is along the positive x-axis direction or positive y-axis direction or positive z-axis direction. If the body is moving in its linear motion, then the velocity is positive. So being velocity a vector quantity, it can be having 0 value, it can be having negative value, it can be having positive value, right? And its dimensions are same as that of speed. That is, displacement is measured in length only, and time is measured in t. That is equal to L t raised to minus 1. So dimensions are m raised to 0, L raised to 1, and t raised to minus 1. That is 0 in mass, 1 in length, 1 in length, and 1 in time, not minus 1 in time, better you speak, 1 in time. Next is uniform velocity. Uniform speed we have explained. In the same way, uniform velocity also can be explained. Uniform velocity means if a body covers equal displacements in equal intervals of time. And this is called a uniform velocity motion. Uniform velocity motion is usually mentioned as uniform motion. Today onwards, you understand that whenever a physics teacher speaks or you read your book, body is executing uniform motion. It means the body is executing uniform velocity motion. Body moves in a straight line towards a particular direction. And in that motion, the body covers equal displacements in equal intervals of time. The velocity is said to be uniform velocity, right? Am I correct? Next is the body can have variable velocity also. Variable velocity means if the body covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time, then the body is said to be executing variable velocity. When the body executes the variable velocity, here also we will calculate instantaneous velocity and average velocity, right? Instantaneous velocity is same thing. Vector v is equal to ds by dt, you will write. Where ds is the displacement and dt is the small interval of time. So the small change in time divided by very small change in very small change in displacement divided by very small change in time is what you call the instantaneous velocity, right? Instant velocity means velocity of a particle at any instant of time, right? And average velocity means the total velocity divided by total time. Suppose the body is moving with the velocity v1, constant velocity v1 for a time t1 seconds, and another duration of time t2 seconds. It is executing motion with velocity v2, and a third interval of time it is executing its motion with a velocity v3. Then total velocity v1 plus v2 plus v3, the whole divided by t1 plus t2 plus t3. Average velocity can also be obtained, right? So suppose this is the origin. I am now explaining you that how displacement, how the velocity of a body can be calculated in uniform motion, right? Okay, this is the situation. Suppose that this is the origin, because always there must be origin. Origin means the observer is standing at this position, right? Okay, this is a point A, this is a point B, etc. Okay, this is along the x-axis. A body is moving in this direction. A body is moving in this direction, right? So at any instant of time, t is equal to 0. The body was at t is equal to 0. And this is t is equal to t1. And here it is t is equal to t2. Okay, right? Okay, right. When the body is at this point, the distance traveled to the body is the displacement of the body is equal to x1. And the body reaches the point B, the distance traveled is equal to x2. Always the displacement must be measured from the origin only. From the origin only, right? Then displacement of the body from t is equal to 0 to t is equal to t is equal to 0 to t is equal to t2 is given by OB minus OA. This is O. O is the origin. Always the distance displacement must be measured from the origin only, right? Okay. So body is starting this point at any instant t is equal to t1, its displacement is x1. And when the body reaches the point P at the time interval t is equal to t2, when time interval t is equal to t2, the body reaches the point P. The body is traveling along the x-axis, right? Then from t is equal to 0 to t is equal to t2, the total displacement of the body is given by vector OB minus vector OA we can write. Right? Vector OB minus vector OA. Vector OB is equal to what? That is vector x2 minus vector x1 also we can write. X2 minus x1. So displacement is always measured from the origin. What is x2? X2 is the displacement of the body from the origin to the position D when time t is equal to t2. What is x1? X1 is the displacement of the body from the origin, always origin. Displacement must be measured strictly from the origin only, right? Now, what is time taken? This is the displacement. Time taken. Time taken is equal to 0 to t2 minus 0 to t1. That is equal to t2 minus t1. That's equal to t2 minus t1. Now, velocity. Velocity vector v is equal to x2 minus x1 divided by t2 minus t1. This is the situation. Okay. So suppose that x1 is equal to 0. X1 is equal to 0 and t2 minus t1 is t2 minus t1 is equal to t, and x2 is equal to xt. That means at any instant t, the body has a displacement is equal to xt, and at the 0 at the time t is equal to 0, the displacement is equal to x0. Then this relation can be given as equal to xt minus x0 divided by t2 minus t. T2 minus T1 can be given as equal to T. T means T2 minus T1, right? So, B means T is equal to T seconds. When time T is equal to T seconds, suppose the displacement is given by notation xt. And x0 means at T is equal to 0, the displacement was x0, right? And between these two intervals, of the position of the body from x0 to xt, how much the time the body has taken, that is equal to t. Then velocity can be given as equal, this can be written as equal to this also velocity only. Am I correct? So this is for uniform motion I am talking about. A body is executing uniform motion at the t is equal to 0, its position is equal to x0. At t is equal to t, its position is equal to xt. Right? Okay. And the t and 0, the difference in time is equal to t minus 0 is equal to t only. Then velocity of the body moving to uniform velocity is given by final position minus initial position divided by the total time taken. So this is also a very important relation. So using this relation, we can write xt minus x0. Xt minus x0 is equal to v into t, we can write. So v into t. Okay. Xt minus x0 is equal to what? V into t. This is position. So we are finding the position of the body and t is equal to 0. Then we are finding the position of the body at t is equal to t. Displacement is equal to position at a t minus position at a 0. That means xt minus x0. Right? The displacement is final position minus initial position is the displacement. And time taken is final time t minus initial time is equal to 0. T minus 0. T minus 0 is equal to t only. Right? In that sense, we can write like this also. Xt minus x0 is equal to v into t. In this case, what we consider is the body is traveling with a uniform velocity. Everybody knows what is uniform velocity. When a body moves with the equal displacements in equal intervals of time, the motion is said to be uniform motion. body moves with the uniform velocity, the motion is said to be uniform motion, right? Now we can write this relation also. That is, xt is equal to x0 plus vt. Xt is equal to x0 plus vt. This is the equation for uniform motion of a body. Very important place. Right? What's an equation of? Equation of uniform motion. Uniform velocity motion. Uniform motion means uniform velocity motion. So if I